Hi everyone, welcome to the day 13 video. In this video we're going to go through number 2 of the AP style questions from our notes packet. Just a reminder that next class the full packet, the area function packet, is due, and that will be collected and graded for correctness, so make sure to have that ready to go. At the conclusion of this video, any time that's left in the period, you will have to work on that. We're going to pause the video for 4 minutes for you to get your materials out, your notes packet, and to also read through this question too. It's the one about the amount of water in a storage tank. So we'll go ahead, pause it now, give you a chance, read all the way through part A. So in the question, they give us two functions to represent the rate that either the water's entering or leaving. And in part A, we just want to know how many gallons have entered the tank. The functions we have are a rate. So to go from a rate to a unit of gallons, we're basically going backwards one or up one in terms of our derivatives. So rate is like a first derivative. We want to go to what comes before that. So we would want to do an antiderivative or an integral. So we're just going to be doing an indefinite integral. We wanted to know from times 0 to 7. And the key is we're just doing entering the tank. Entering the tank is the function that was given in I. So we'll just have 100 t squared times sine of square root of t, and then a dt at the end. And this is a calculator problem. This type of problem usually shows up as question 1 on the free response of the AP exam, and questions 1 and 2 are always calculator questions. So we're going to pause the video for a minute for you to punch this in your calculator. Make sure you are in radian mode as you do that. So we should have gotten 8263.80. Check for rounding. They want to the nearest gallon. So we should have 8264 and stick your units on that for gallons. Now, after each part of a free response question, it's important to read the question and make sure you addressed each of the things that they asked for. Sometimes questions could ask for 2 to 3 responses within a single part, and it would stink to lose points if you just didn't read carefully enough and address one of the things they asked for. So we wanted to know how many gallons, and that's all they asked for, so we're in good shape in this part. All right, take a moment and read part B. So again, the information that was given to us in the problem are functions representing the rate that things are coming and leaving in terms of the water. So the tank should be, the amount of water in the tank should be decreasing anytime we let more water out than we are letting in. Or in other words, when the rate of leaving the tank is greater than the rate of entering the tank. So what we're looking for is we want g of t to be greater than f of t. G of t is our step function there, the horizontal lines. In terms of t's, our g of t is greater in that section, and then it's greater in roughly that section as well. So our intervals, we would start at 0, and notice 0 is included in that. So we would have 0, 2, where that intersection point is. Now they conveniently told us the intersection points in our question. So we'd be 0 to 1.617. Now we would not want to include the 1.617 because that's where they are equal, so therefore there would not be a decrease in the tank. And then another interval starting at 3 and going to 5.076. We need to give a reason, and our reason would be since the rate of water leaving is greater than the rate of water entering. Now, I chose to write that in sentences. You could have also said simply since g of t is greater than f of t, because those have already been defined as the entering and leaving functions earlier in the problem. All right, take a moment and read through part C. So if we want the amount of water in the tank to be greatest, that means we want the amount of water in the tank to be maximized. This is an optimization problem. The first free response question on the AP exam almost always has an optimization part, and it is the biggest number of points in that part. As you saw, parts A and B here were pretty quick. A full free response question is worth 9 points, so those first two are probably worth maybe 2 each, and then probably about 5 of the points for the optimization part here. So remember our EIDCT. So first we want to come up with our equation. So I'm going to list our EIDCT. You don't necessarily have to list those letters as you do the problem if you don't want to. So we need an equation that represents the amount of water in the tank at any given time. So I'm going to call that A of T, just for amount of water. Our amount of water in the tank has to take into account 3 things: the amount of water we started with, the amount of water that is left, and the amount of water that is entered. So you almost always start with whatever your initial amount is. So here we had 5,000 gallons. Plus, we're going to have an integral from 0 to 7, and we just need our entering amount as a positive and our leaving amount as a negative. The simplest way to do that is just do our function f minus our function g, and just using that notation of f and g. Actually, I got to fix one thing. Hold on one second. We don't want this to be 7 because it's not always going to be 7. We want t there because we want to find our number of gallons of water from the starting time to any random time that we want. Now, inside here, we can't use t because we needed t to match the t in our A of t. So what we pick is a dummy variable. It can be any other variable that's not used in the problem. I'm just going to go with x. So we would put in here f of x minus g of x dx. And this is our equation that represents our water in the tank at any given time. If we wanted to know at 2 hours, we'd have A of 2, and we would just do our integral from 0 to 2. Now, one thing that's nice on the AP exam, they always give you the interval. So I'm just going to write my I up here. We're going 0 to 7. I want to point out that we have a closed interval, so we have to remember at the end of the problem that we will need to test our endpoints. Next is our derivative. So we're going to do a prime of t. Derivative of a constant 5,000 is 0. Derivative of our integral, notice our integral goes from a number to an algebraic expression on top. This is where knowing our second fundamental theorem of calculus makes life easy. We have seen in the past few classes that when you take the derivative of that integral, in the long run it just ends up with the t going where the x is. Now, technically, we saw when we did this second fundamental theorem of calculus, we're subbing that t in, and you're technically multiplying afterwards by the derivative of what you subbed in. But because derivative of t is just 1, that doesn't end up playing a role here. If hypothetically it had been a t squared that we were subbing in, then we would have needed to multiply by 2t afterwards. But in this particular case, it doesn't play a role. And usually on these optimization ones on the AP, it's not going to play a role. So next we need to find our critical values. So we'll set our derivative equal to 0. If we add the g of t over, that's just simply when g of t is equal to f of t. So our critical values are just those ones that they gave us in the question where they intersect. So t equals the 1.617. T equals the 5.076. Now when it comes to our number line, we also need to consider places where the derivative didn't exist. So in our picture, notice at t equals 3, our rate for g of t did not exist. So we're also going to have to put 3 on our number line as well. So we'll now do our test. On our number line, we're going to have 0, 1.617. We're going to have the 3, where that g of t, that rate function did not exist. We'll have the 5.076, and then we'll have our end of the interval, which was 7. If we label, this is going to be a prime of t values on top and t on the bottom. And we're going to get our pluses and minuses just from the graph. Remember, a prime of t was f of t minus g of t. So in this first section right here, g of t is the bigger one. That's higher up on the graph. So we're doing a smaller minus a bigger, so we should get a negative. In that next section, this section here, now the curve, the f of t is greater, so it's a big minus a small, so we get a plus. And if we keep going, after 3, it now switches to the g of t being larger, so we'll be back to a negative. And then after the intersection point, the curve is larger, so we'll come back to a positive. So we're using the graph in this case here to help us get our pluses and minuses. You hypothetically could have used the equations as well, but it's just quicker to use the graph. So we were looking for a maximum. So on our number line, we're looking positive to negative. So we would have t equals 3 is a relative max since a prime of t switches from positive to negative. And then we need to test our endpoints. So we are going to test a of 0, a of 3, and a of 7. A of 0 is just our initial value. That was 5,000. A of 3 will be 5,000 plus the integral from 0 to 3 of f of x minus g of x we had. And actually, why don't I'm going to go ahead and fill in the f of x and g of x now. If we're going 0 to 3, f of x was the 100 t squared sine of square root of t. So again, I'll just stick with the x that we used for the dummy variable. So that'll be 100 x squared sine square root of x minus our g in this case. Well, if we're going 0 to 3, g is just 250. So we'll have minus 250, close my parenthesis dx. And we're going to pause the video for a minute for you to punch that in your calculator. Again, make sure you are in radian mode. So we should get 5126.591 and change. And now we've got to do a of 7. Well, because the g function switches after 3, rather than just doing our integral and do it from 0 to 7, we're actually going to take that 5126.591 dot dot dot, and we're going to add on our integral just going from 3 to 7. Because from 3 to 7, g is always the same, whereas if you did it from 0 to 7, we would have to split up that integral anyway. And then now instead of the minus 250, we are going to have the minus 2000. And we're going to give you a minute. We'll pause the video, see if you can plug this in now to see what we get for our gallons at the end of the interval. So we should have gotten 4513.807 and change. So now we want to see what the question asked for. It's good to reread that question, make sure we have what we want. So for what time t is the amount of water in the tank greatest? So we need to give a time for our first answer. Here is when our water is the greatest, so it would be t equals 3, and our time unit that we have is hours. So that's our answer for that part. But if we keep rewriting the question, the second part says to the nearest gallon, compute the amount of water at this time. So we also need our water to the nearest gallon. So we've also got 5127 gallons. So this is an example of one. Be careful to reread the question to make sure you've addressed all parts, because it would stink to say just give the gallons amount and not specifically state the time, or vice versa, and end up losing a point when we've done all this nice work. The justify is just all our work that we've done. Justify could be mathematical or explanation. If it said explain, you would want some written justification for it. All right, so that's the end of this video. Any time left in the period, you can work on your area function packet, and remember that is due next class. Have a great rest of your day.